Alright, number 39. It says the table below shows the cost of a pizza based on the number of toppings. And they give us the table, and it says which function represents the cost of a pizza within toppings. Well, I'm looking at this, and right away I see that these are increasing by $1.50. So each topping that I add on is going to give me an extra $1.50 to my price of the pizza. Alright, so those are all the same. So looking at my equations, the only ones that take that into account are going to be B and A. So I already know C makes 0 sense, D makes no sense because they're not taking into account the cost of adding on a topping. So when we talk about, this is actually an arithmetic sequence. If we continue to add the same amount, it's arithmetic. And with an arithmetic sequence, there's two ways to do the formula. We could do like f of x equals the initial amount, okay, plus the slope, and we can use different symbols to show this, but it means the same thing. So the initial amount, meaning the first term, plus the slope times x minus 1 term. So that's one way to do it. So we could prove that A is correct by doing this because our initial amount is 12. That's what we started with for our first term. So we just plug in a 12. Our slope we know is 1.5, so plus 1.5. And here they used n instead of x, so it would be the n minus 1 term. So I just proved that A is right by that formula. Now, I also teach it another way, so just using slope and y-intercept. Here, n is 1, but what about when n is 0? What if we had no toppings, just like a cheese pizza? Then we'd have to go back in our table. And how would I go back? I would have to subtract 1.5, right, or 150. So 12 minus 150 is 1050, and that's technically my y-intercept, because that's at my 0 term. So another way to write this is using slope-intercept form. So we can do y equals mx plus b, where m is my slope. So it would be y equals, my slope is m, so I'm going to say 1.5x plus, and then my initial amount would be 1050. Now the only problem is they are not using any of those, well, I guess C and D did, but I mean A and B are the only two plausible solutions, are not written in that form. So which one of those is technically equal to this would be the question. And if we go ahead and do one step with distributive property, we can prove that A is the right choice. So 1.5 times n is 1.5n. 1.5 times negative 1 is negative 1.5. Bring everything down and combine your like terms. So 12 minus 1.5 gives us 10.5. So it's 1.5n plus 10.5. So we just proved it both ways, and I like the slope-intercept form personally, but you may like the other formula for arithmetic. So A is our best choice. So don't just write it off if that doesn't look like they're equal. Make sure that they're always simplified. And answer choice A was not simplified. And this is, and now this is, and they equal each other. Alright, number 40. Paul sells chocolate chip cookies and peanut butter cookies. And I'm actually going to make a table as I read this. So chocolate chip cookies is 1.75 cups of flour, and it is 2 eggs. And baking a batch of peanut butter cookies takes 1.25 cups of flour and 1 egg. And Paul has 10 cups of flour and 12 eggs. Well, that's important because we can't go over that amount for either of them. Otherwise, we have some nasty cookies. He makes $4 profit per batch of chocolate chips. So I'm going to put profit over here for my table. And that's $4. And then $2 for each batch of peanut butter cookies. Alright. My table's looking good now. So, how many batches of peanut butter cookies should Paul make to maximize his profit? Well, I'm looking at this and I see, just using common sense, chocolate chips giving us more money. But it's using a lot more of our product. It's using twice as many eggs as peanut butter. But it's not using as much flour. I mean, just a little bit more, right? So, not twice as much flour. But it's definitely using more flour. So, we need to find out the happy medium, and we want to use up all of our ingredients. Well, there's only 4 answer choices, so my main advice to you is plug each in and test. You have plenty of time on this test, so plug in each value in your table. And that's the best advice I can give you. So, try every one. So, for instance, if I want to do 1 for peanut butter, that means if I use 1 here, I'm going to multiply everything by 1, which, as you probably know, that's going to mean all these numbers stay the same. So we're only going to make $2. So the profit's going to be $2. And I'm just going to put total here, total money. I'm running out of room. Total money is $2. But how much do I have left? Well, if I've already used 1.25 cups of flour, and it says I have 10 cups, I just need to do 10 minus 1.25, and I have 8.75 cups of flour left. Right? So I just divide by 1.75 because that's how many cups it takes for one batch. And I'm going to do that, 8.75 divided by 1.75, and you do have a calculator, so use it. Gives us exactly 5 remaining for chocolate chip. And then we're out of flour. Let's see how our eggs are doing. 5 times 2 gives us 10 eggs, right? So 10 plus the 1, now we have 11 eggs. We have, we've used up all of our 10 cups of flour exactly. And if we use 5 of chocolate chip cookies, 5 times $4 of profit gives us 20. See, I'm just distributing that 5 to each of these. 5 times 1.75 gives us, what do we say? 8.75? Yep. So I just distributed each of those numbers there, and then I added them up. So my total profit is $22 if I use the first choice. I'm going to write that down. So 1 gives us $22. I'm going to do the same table for 2 batches of peanut butter cookies. Now I'm guessing that first choice is probably pretty good, because we had a lot of chocolate chip. That's our money maker. We used up all of our flour, most of our eggs. I'm probably guessing A is a great choice, but I'm going to try B and see what happens. Alright, so if I try 2 of peanut butter cookies, I'm going to distribute that 2 to all my flour, eggs, and profit. So 2 times 1.25 gives me 2.5, or 250. 2 times 1 gives me 2. 2 times 2 gives me 4. So I have $4 I'm making off the peanut butter cookies. But how much do I have left of my product? Well, I can use, it says 10 cups of flour. So I'm going to do 10 minus my 2.5. And that gives me 7.5 is left cups of flour to use for chocolate chip. Well, look, I have 1.75 for each batch, so I just divide it by 1.75 to find out how many batches I can make with my flour. So 7.5 divided by 1.75 gives me 4.28. In other words, I can use 4 batches. I have to round down. So 4 batches of chocolate chip cookies. I round down because that's material or product, and if you don't have enough flour for that 5th batch, it's not going to be a good batch, obviously. So we'll just have a little bit extra flour. So now 4 times 2, and I can double check this. So 4 times 1.75, like I said, we have a calculator. It gives us 7. So if I add that up, I have 9.5 cups of flour. So I'm still under my 10 cups, right? So that's good. 4 times 2 for eggs gives me 8. 8 plus 2 gives me 10 eggs. And then 4 times $4 in profit gives me $16. So look at what's happening. The more peanut butter cookies that we make, the more batches that we make, the lower our profit, because our profit's now $20. And if you have time, I would try every one of these choices. I see a pattern developing. So I know that answer choice A is going to be the best, but I'm just going to prove it real quick. So let's try answer choice C. If we have 5 of peanut butter, 5 times 1.25 gives us 6.25. 5 times 1 gives us 5 eggs. 5 times 2 gives us $10. So now what's remaining for our product? Well, we have 6.25 we've used of flour, so 10 minus 6.25 gives me 3.75 remaining for chocolate chip cookies. Well, that means I can only get 2 batches, because if I divide that by 1.75, it's going to give me a little bit over 2. So I'm going to use 2 for chocolate chip cookies, and I'll double check that. 2 times 1.75 gives me 350. Add up my flour now, and we get 9.75 cups we've used. We can use 10, so we're good. 2 times 2 eggs gives me 4 eggs. 4 plus 5 gives me 9. 2 times 4 for profit gives me 8. And I was right. My pattern continues that the more chocolate chip we use, the better. The more peanut butter we use, the worse. So that's only 18 bucks. And I'll try my last one just to make sure. Alright, so now if I plug in an 8 for peanut butter, 8 times 1.25 gives me exactly 10. Well, let's stop right there. If that gives me 10, I can only use 10 cups of flour. So that means I don't have any flour left for chocolate chip cookies, which means that's 0. So 0 times 4 is 0. I'm not making any money off chocolate chip. 8 times 2 gives me 16. So I only made 16 bucks. Scratch that. So the best choice, of course, is going to be choice A, as we thought all along. It uses up all of our ingredients, and it uses more of our money maker, which is the chocolate chip. I'm just going to end this video with one question to you. What would have happened if the flour was more than twice the amount of peanut butter? And that's my question to you. What if it would have been more than twice the amount? Would our answer be different? So if it would have been, for instance, 275. Alright, and hopefully you're saying that, well, geez, you're using twice as much for eggs, and then you would be using twice as much for flour. So then chocolate chip is only giving you twice as much, but you're using more than twice as much ingredients, so then it would not be your money maker. So in that case, you might want a little bit more peanut butter, huh? So, just something to think about. Man, all this talk about cookies has me hungry.